All right, so this section is dealing with law of cosines, and you use this on triangles. This is actually a lot easier than the law of cosines. So it's actually a proportion, and you can either have it as sine of A over A equals sine of B over B, or sine of C over C. It's just a proportion, but there are actually three scenarios. Sometimes you have one triangle, sometimes you have two triangles, and sometimes you have three triangles. So this first part, you can see the one on the left. That's when you have an oblique triangle. The one on the right is when you have something when angle C is between 0 and 90 degrees. So that's not necessarily a right triangle. It could be a isosceles or an acute triangle. So if you wanted to just quickly solve this problem, using similar to the other video that we had, we could probably do this pretty easily. So if we were to set this up, this particular problem, we could do something like the sine of 115 over sine of 115 over 45 is equal to the sine of 27 over b, and then you cross multiply, so you get b sine 115 equals 45 sine 27. So b is equal to 45 sine 27 all over sine 115. So then that gets you something around 22.5, right? And so I have that angle, and I should be, so I have that. I have side B is 22.5. And then if I want to get side C, I can do sine of 115 over 45 equals sine of 38 all over C. And I do the same thing. If I cross multiply, I'm ending up with C equals 45 sine 38 divided by sine 115. And that comes out to be about 30.6, right? So I have that. Where did I get that 38 degrees? Well, that's because all three angles in a triangle add up to 180, right? In case you're wondering that, I think I kind of missed that. What I want to talk about next is the types of the ambiguous case. In this case, the side-side angle. Sometimes you have a side where a triangle can't happen. Sometimes you have it where one triangle happens. Sometimes you have it where it is two triangles that happen. So this one, you can see that if side A is less than side B, A is too short to reach the third side, so there's no solution. If A is less than B here and it just barely reaches, it's kind of like a perpendicular to, so you have one solution. And sometimes if A is less than B, there's a possibility where this thing can swing out, and so you have two answers, this triangle right here and the other one right there. And then there's also the one triangle here. And that's when A is greater than or equal to B, so you know it's good to go. So you have to consider those things when dealing with this. All right. So all three of the triangles, side A is considered what's called the swinging side, and side B is called the fixed side. So you have to take these into consideration. All right, so there are two ambiguous cases with side-side angle, and that's when the A is greater than 90 degrees. So you just have to be mindful of it, and you either have no solution or one solution. So let's look at a problem and how you have to deal with how that works. All right, so given a possible triangle ABC with B is equal to 8 and C equals to 5 and angle C is 54 degrees, find angle B. So we draw a triangle. Now here's the thing, since the exact shape is unknown, we're going to do basically 54 degree angle. Side C must be across from angle C, so we place side B as being 8 and adjacent to the angle, and C is going to be 5. Since the angle is unknown, we can attach side C to B. We just don't know the angle in which they meet. So side C, the 5, is called the swinging side. Now, what's possible is that this is the center, so realistically this side can make a circle anywhere around here. All right, so depending on what h is, so what I got to do is I have to figure out h. So let's figure out h. If we're using right triangle trig, we can say that the sine of 54 is equal to h over 8, and then so h is 8 times the sine of 54 degrees. So h is approximately 6.5. Well, that height is bigger than the length of side C, so there is no way possible you can have a triangle. All right, well, how does, I already got that. So how does this come into play? All right, if we look at this, I'm going to move this up a little bit. Lighthouse B is 3 miles east of Lighthouse A. Boat C leaves Lighthouse B and sails in a straight line. At that moment, the boat is 5 miles from the Lighthouse B. An observer at Lighthouse A notices the angle determined by the boat, Lighthouse A, which is the vertex, and Lighthouse B is 65. Approximately how far is the boat from Lighthouse A at the moment? So this one, again, you think about the height, and I gotta move this over a little bit because I drew it in there. All right. So you have the height, and you have to think about that for a second. The swinging side is now the A, because I knew that this angle is 65. So side CB is my swinging side. All right. So the swinging side is longer than the fixed side, which is 3. It will automatically be longer than the height h, and it will form exactly one triangle. That's what we said. So let's find this one triangle. So if you have the sine of 65, and that's over 5, is equal to the sine of C over 3. We cross multiply, we get something along the lines of 3 sine 65 equals 5 sine C. We divide that, so we get sine C is equal to 3 sine 65 over 5 over 5, right? And then so C is the arc sine of 3 sine 65 over 5, which comes out to be approximately 32.94 degrees. All right, we got that part, but we needed that for what? Well, we got to figure out how far apart the boat is. So we got angle C. Now that we got angle C, we can figure out angle B. Angle B is 180 minus 65 minus 32.94. So angle B is about 82.06 because we said that angle C was 32.94, right? So we did that whole triangle thing. Now, set up a proportion. Sine of 82.06 over B equals the sine of 65 over 5. So B is 5 sine 82.06 all over sine 65. That comes out to be about 5.5 miles. Okay, it comes out to be about 5.5 miles. Everyone okay with that part? Awesome. We got that. Now here's this guy. Again, we have this triangle, and they give us these sides. You got to find the height of h in order to see if it is possible. So in this case, we're going to do the same thing we did before. Sine of 28 is equal to h over 6. So h is 6 times the sine of 28 degrees. So h is 2.8. Well, since that is smaller, we actually have two triangles now. We actually have two triangles because this guy can come right here and form a spot, or it can keep spinning and form a spot like that. So you actually have this triangle and you have this big one right here as well. So we're going to look at each one of those. All right, we're going to look at each one of those. In the first part, I got to add a page here. In the first part, we're going to have this guy right here, where that's A, that's B, and that C, we already know that that's 4.8 because we found that to be there. And so, um, and that's 6, I believe, right? That's 6, that's 4.8, and we got the 28 degrees. I guess I'm going to call this C1. This would be B1. And then, okay, so you got that set up, and then there's the other one. There's the other triangle that looks something like this, where you have, it's the big one where you go like this, something like that, and you got A, C. We'll call this one B2, if that makes sense. And again, it comes in, and here's where that other guy came from, and we'll call this B1. So this is C1, and so let's figure this out. So this guy, this triangle right here is 28, and we have that. So let's figure out sine of 28 degrees over 4.8 over 4.8 equals, okay, so we got those two triangles. I'm trying to figure out what I was doing here. All right, so you got this. Let's go with the big one here. This is 6. You know that that's 6 right there. And so that's 20, and this is 28 degrees. And then this is 4.8. So that's how you're setting that one up. And what do I want to do here? So I'm going to do sine of 28 over 4.8 equals the sine of B2. That's what I wanted to do. That'd be easier. Sine of B2 over 6, if that makes sense. So then you cross multiply, you get 4.8 sine B2 equals 6 sine 28, if that makes sense. So sine of B2 is equal to 6 sine 28 over 4.8, creating, if you take the arc sine of that, B2 is approximately 35.93 degrees. So B2 is about 35.93 degrees. So how do I get this distance? I guess we'll call this C2. How do I get this distance C2? Well, I already have this to be 35.93 degrees, right? I have that as 35.93 degrees. So this angle right here must be 116.07. So then I'm going to set up sine of 28 over 4.8 equals the sine of 116.07 all over C, I guess we'll call, or C2. And then cross multiply, you get left with, and you solve a little bit, you get C2 equals 4.8 sine 116.07 all over sine 28, right? So C2 is approximately 9.2. If that makes sense. Now for the other, now for the other part of that triangle, and that's this one right here, right? The other part. So this guy is 28, this guy is 6, this is 4.8, right? This is 4.8. So we know that that angle, this angle right here, so this is A, and I guess this would be B2, I guess. And this is C, so we know that this angle right here is 144.07. And how do I know that? Because it's basically How do I know that? You got the 28. Oh, because this is an isosceles right here, because it's swinging. So this is 35.93. That's why. So since these guys are isosceles, I can get that angle right there. And that's because this one and this one have to add up to 180. That gives me, um, yeah, that gives me that. So what do I got to do? All right, so I set up sine of 28 over 4.8 equals the sine. I guess this is going to be 7.93 now. So the sine of 7.93 over C1, I guess. And so when you cross multiply, you get C1 equals 4.8 sine 7.93, and that's all over the sine of 28. So C is 1.4. So um, basically we have two situations. We have where you have one angle B. There's two triangles. There's one angle B which is 35.93. One C situation where it's 116 C angle, 116.07, and then where side C is equal to 9.2. But the other one, you have the other possible angle is 144.07, and then the other angle is 7.93 degrees, and then the other length is 1.4. So you have to be mindful of that. So what we're going to do in class, next day in class, we'll be looking at a problem like this with the surveyors, if that makes sense. Make sure we cover all of that. And then we're going to talk about the area of a triangle. So hopefully you understand what I was doing. I look forward to seeing you in class, and may the force be with you.